Welcome to our second exam review. If you've not already done so, I encourage you to make sure you've worked the questions out ahead of time and then come back and actually watch me work them out, or at least check your answers that way. We're going to start with number one. Compute the annual cost of each of the following expenses. $16 a week on soft drinks, $170 per month on renter's insurance, and then complete the following sentence. On an annual basis, the first set of expenses is blank percent of the second set. Okay, so we're going to need a calculator handy for this, or Excel, one of the two. And first thing is to figure out how much we spend a week on soft drinks. Okay, so if we spend $16 a week, there are 52 weeks in a year. And so 16 times 52, we're spending $832 on soft drinks. And then on renter's insurance, we're spending $170 a month. And there's 12 months. So multiply those together. So we're spending $2,040. Okay, so that's the first part, is to figure out the annual expenses of these things. The second question is asking us to calculate a percent. So the first expense is blank percent of the second. Okay, so I want the first number as the part and the second number to be the whole. And then, then I want to divide that. Divided by 2040. So I get 0.4078. So 40.8% of renters, and so in other words, the soft drinks is 40% of the cost of what we pay on renter's insurance. So it's just a number to keep it all in perspective. Number two, Debbie maintains an average monthly balance on her credit card of $1,250. Her credit card company charges 18% annual interest, which is billed at a rate of 1.5 per month. How much is she spending on her credit card interest per year? Okay, so just a quick side note here. If I take the 18 and I divide it by 12, that's where we're actually getting 1.5 from. Okay, so if each month she has a balance of 1,250, then she is paying the credit card. Let's see, 0.015 times the 1250. So she's paying the credit card each month. Once I get that figured out, $18.75 just to have the money. And so if I take that number times 12, then in a year she spends $225 on interest alone. All right, number three, find the net monthly cash flow. We're saying 1 month is 4 weeks. And I guess we're also saying that 52 weeks in a year would be worth mentioning. Okay, so first we need to calculate income and then calculate expenses per year. And then we'll add the two numbers together, or subtract them because one will be negative. And then divide that by 12, and that'll tell us what her monthly cash flow is. So from her job, she gets $700 a week. So 700 times 52 is 36,400. And she's taken out a student loan in the spring and the fall. So she's also getting 5,000 times 2, or $10,000 total. And so if I add up both those numbers, she's getting 46,400 for her income. Expenses, she's got rent at $750 a month. So it's 750 times 12 is 9,000. She's got groceries at $75 a week. So 75 times 52 is 3,900. Tuition and fees is $27.50 a semester, so $27.50. And again, we're just assuming fall and spring. And that would be 5,500. And then miscellaneous per week would be 150 times 52. So that's 7,800. Okay. So then I want to add up all of those numbers to calculate what she's spending. Okay, so I get, when you add them all up, you get 26,200. And then I want to subtract her income minus her expenses. Okay. So on a yearly basis, she gets 20,200 net. That's positive. So then her monthly cash flow, so then I want to take that and divide that by 12. So that would be 1683.33. So in other words, for these are the expenses that we're aware about. So she's got another $1,600 that she can play with each month, and hopefully, she keeps on top of it. Hopefully, she can put some of that away for savings. Okay, number 4. Suppose we invest $900 in an account that earns simple interest at a annualized percentage rate at 5.7%. Determine the accumulated balance after 8 years. Okay. I'm going to go to the formula chart. Now, we do have a specific formula for simple interest, but I want to show you with the tools that you have for this test how you can get in the habit of using the formula chart, and hopefully this will work for you. So we have this formula that says compound interest paid n times per year. Now, simple interest is they look at the original amount and they give you just that. So that's going to modify this formula a little bit for simple interest. So simple interest, we don't have this compounding, so we don't have this divide by n piece. And it's a constant amount that we're adding on there each year. So let me come back over here and show you then. So it's after just the first year, so 900, 1 plus 0.057 will tell us what we get at the end of just the first year. So 900 times 1.057. Okay, so at the end of the first year we have 951.3. Now, if this was compounding, we would use the 951.3 for the second year, but we don't. We just recognize that in any given year, you're going to get $51.3 in interest. So then to calculate what happens at the end of 8 years, it's going to be 900, so the original balance plus that constant interest we get each year times 8. So 900 times 51.3 times 8. Oops. 0.3 times 8. Okay, so at the end of 5 years, she'll have $1,310.40. I'm sorry. Number 5, suppose we invest $12,000 in an account that earns 4.1% compounded annually. Determine the accumulated balance after 6 years. Okay, so this is kind of a variation of that first question, except now we get to compound it annually instead of the simple interest. So again, I'm going to go, oops, I'm actually going to show you that one on this one. Okay, so I'm going to set it up using this, but we get to actually use the exponent in this case because we're compounding. So it would be, accumulated balance, would be 12,000, 1 plus 0.041. Well, okay, 0.041 divided by something, something times 6. Okay, so I did kind of leave it on a blank for just a half second here, because we are compounding annually. That means they're going to look at it once per year, and so we can do that. Now at that point, we can just type it in a calculator. Let me show you another option using this financial template that I kind of left as something for you to play around with. Now these are not the right numbers, obviously. See if I can minimize this and get it on the screen at the same time. That'd be nice. Okay, so I'm looking in this first box, I'm looking at future value. That's what that accumulated balance means. So I need to change my numbers to match what I'm told. So I need the 4% to be 4.1%. Oh, sorry, I wanted to be at the same time. Okay, so that I'm going to say 4.1, and it will automatically convert the percent to me. Compounding periods in a given year, it only looks at it once. Present value, so I start off putting in 12,000, but it's money I give up, so I don't get to spend it. So I'm actually not having $12,000. Although the sign's not going to make a big difference. I am not making any additional payments at all, and it's at the end of 6 years. Okay, so if you use, so in other words, there's the answer. Or if you just want to type it in the calculator, that way you can get that. So 15,271.64. Okay, number 6 is an example of compound continuously. So I'm going to show you right there. Sorry, there's the phrase compound continuously. So if I go to the formula chart, the compound continuously is right there. So it's it's the PERT formula that I talked about in the lesson. So the accumulated balance would be 2,600 times E raised to the RT power, so 0.062 times 7. Okay, so if I type that in the calculator, give me a second here. Okay, so we should get 4,012.89. Now, just to show you that the financial calculator will work in Excel, the little formula we used a second ago. Let's see. So let's change APR is 6.2%. Okay, compounding I'm going to come back to in a second because continuously involves that E, so that's a little bit different as far as our thinking goes, but you'll see how it's going to work. So 2,600, sorry, negative 2,600. Not that it's a big deal because it just makes it red. And after 7 years. Okay. So what I want to point out here is if we're compounding continuously, that means we're compounding more than quarterly, more than daily, more than, we're compounding more than hourly. So notice what happens when I go, let's go from 1 to 12. So 12 would be compound monthly. Notice it went to 4008. If I do it daily, it's 4012. But notice it's getting slower and slower. So all I have to do for compound continuously is just type a really big number in there, and notice it's not doing anything. We can't really see what it's changing. It actually matches pretty close to what I got. So I think if I go one more zero, so 1, 2, 3, 4, 5, 6. There you go. So you can still get the spreadsheet formula to still do it for you to get the 4012.89. Okay, so number 7 is asking that we want to start a retirement fund for our newborn so that she has $1 million at age 65 when she retires. How much will we need to deposit now so we can obtain, how much do we need to put in there today at this constant interest rate, compounded continuously? And then it throws in that statement about no additional deposits are going to be made. Okay, so it's a little deceptive as to which formula we really want to use. We don't want, go to the formula chart here, we don't want the savings plan formula that requires regular payments because we're not making regular payments. We just want to stick the money in the account and let it sit there. That's actually this PERT formula that we just used in the last example. But instead of having P, we're going to solve for P. So let me go back. Okay. So I want to have $1 million equals P because that's the balance, that's the principal, the balance that we're going to start off with. E raised to the 0.095 times 65. Okay, so I want to figure out that number, and then I just want to divide the two. So let me start by figuring out what that number is equal to. 0.095 times 65. Okay, so it's this really big number. Okay, bear with. My program is acting all glitchy. Okay, so we got 1 million equals P times, and that piece equals about 480.58. And then to solve for P, I just divide the two numbers. So 480.58. And that's going to tell me what the initial principal needs to be. Okay, so 2080. 0.8, looks like 81. There's sort of an interesting thought. So if you stick $2,000 in a account and just let it sit there and accrue interest, if you can find anything like this to get 9.5% interest, I'm afraid you'll find in the real world that's not a very realistic number. However, let me go to our Excel chart, and again I'm looking for something about present value. So there's future value, there's how many years to do something, amount we get on interest, there's present value. So this guy right here will do this for us. So let me get it so I can type some numbers in. Okay, so I need an interest rate, which is 9.5%. Compounding I'll come back to. Future value. Okay, future value, I want that equal to 1 million. Present value is, sorry, payment. I'm not doing any payments. I'm just going to let it sit there. And 65 years. Okay. So remember, with compound continuously, we just needed to look at our account an incredibly large number of times, and we ended up doing like 100,000. Ended up being just big enough to do that. Anyway, so you can see that we get the 2080 that we got using the calculator. So anyways, it works, yay.